Okay, thank you very much. Oh, great. So we have an instructional coach with grasslands uh, and a strategies program. Excellent. That's interesting. Awesome. Okay, well then let's get started. Before I get started, I just want to ask anyone who is able to keep their cameras on. I would really appreciate it because it's so much easier for me to do a presentation when I can actually see people in my on my screen rather than just talking to my slides. Um, but if not, I totally understand. I'm not going to make you do anything you're not comfortable with or you are doing other things. People often come on and they are, um, what's it called? Multitasking. Um, and it's okay, whatever you decide to do. So anyway, once again, oh, thank you guys. It does make my life a lot easier. Okay, so before we begin, oops, I just wanted to respectfully acknowledge that we are located on traditional lands across the province of Alberta. We are on Treaty 4, 6, 7, 8, and 10 territories, the traveling route, gathering place, and meeting grounds for Indigenous peoples whose histories, languages, cultures, and traditions continue to influence our vibrant community. We are grateful for the traditional knowledge keepers and elders who are still with us today and those who have gone before us. We recognize the land as an act of reconciliation and gratitude to those whose territories we reside on or are visiting. Honoring the land in this way acknowledges the story of the creation of this country in a way that has historically been missing. So, who am I? I notice I recognize some of you. This is not your first time being at one of my sessions, so you've probably seen this slide. But I'm Yelana Seletsky. I'm a mother of three young ladies who are now officially, all of them are finished school and post-secondary. I am a retired teacher from Greater St. Albert Catholic Schools. So Sarah, that's why I was asking if you were with G Sacred or with Sturgeon. And I taught there for 37 years, and I during my 37 years there, I was blessed enough to become a math consultant in my last 15 years. And during those 15 years that I was there, I also went on and I was seconded half time to the Edmonton Regional Learning Consortium. And then when I retired, just went with the ERLC and have been working on a contract with them for the last, well, 2+ years. When I first retired, I cried. I didn't know if I did the right thing because I absolutely loved my job. And then COVID hit, and I realized I really did do the right thing. and totally have a totally new respect for teachers. Like I always respected teachers my entire life, but a totally new respect. I've also been working for Pearson Publishers with their math resource called Mathology, and I was a reviewer for it. And in the last year, I also went on my very first retirement trip, and I went to the Tahitian Islands. So I was in Tahiti and Bora Bora, and oh my goodness, I can't even remember all the names. Moorea. I did 7 islands in 8 weeks, and on every island swam with the sharks, which was a real experience for me. And did a lot of hiking through the rainforests and swimming in the ocean. It was just amazing. So for all of you out there that are young and Sarah new to the profession, it really is a beautiful profession to retire from, and there's a lot of good stuff that comes after retirement. So when I was a consultant in a school district, the thing that came up often was my students don't know their basic facts. And in grade 4, 5, 6, 7, 8, 9, and then all the way into high school, I was hearing more and more teachers say, my kids don't know their basic facts. I'm going to challenge you a little bit today to realize it's not just the basic facts that they may not understand. They may not understand what does adding and subtracting mean, and then they may also not understand um, place value, because knowing your basic facts stops when you're adding your basic facts, adding your single digit numbers. Yeah, it helps you to know your basic facts, but learning your facts through strategies that can be moved past the single digits, but can be moved into the, double digits, triple digits, and then into the thousands, and then in grade 5 into the millions, and also adding using the same strategy for adding and subtracting decimals. You you don't want to teach a strategy that, excuse me, that you can't use with more than just the basic facts. And so I just want to go through the scope and sequence for you. The scope and sequence, it starts off with kindergarten, where they start to compose and decompose numbers to 10, not saying that they add numbers to 10. It means that they learn all the different ways of making, for example, 5, that I can make it with a 1 and a 4, a 3 and a 2, or a 2 and a 3, and then how many different ways can you make 9? And so they decompose those numbers up to 10 in kindergarten. In grade 1, in grade 1, they start doing adding and subtracting to 20. And what they do also is they not only learn their basic facts to 20, but they compose and decompose all the numbers to 20, and they go beyond, all the way to 100. In grade 2, they actually take that knowledge that they've learned in grade 1, and they start to do addition and subtraction within 100. Even though they've been composing and decomposing numbers to 100 in grade 1, they just do their basic facts. In grade 2, they take that knowledge of all the different ways of making numbers to 100. Like, for example, how can I make 52? They know that it's 5 10s and 2 1s, but now we're going to go and add those 2-digit numbers. And so that is new. Anything that's in yellow is new in the new curriculum. And so grade 3, they now add and subtract within 1,000. Grade 4s, well, if your kids struggle, they may have missed some of the foundations, because now they're going to be adding and subtracting to 10,000, but now they're adding in their decimal numbers to hundreds. So they could actually be adding 6-digit numbers. But I say, when we're working with them, I help them really understand what they're doing when they're adding their decimals in the first place. Grade 5s, they add and subtract to 1 million using their decimal numbers to thousands. And now this is where we start introducing algorithms. And grade 6, they will add and subtract using algorithms and money and metric measurement. And so it is assumed that by the time they get to grade 6, that they are quite fluent in adding and subtracting. And I can tell you, if I was to ask any of you here that teach grade 6, you'll probably say, yeah, that's not true. That's not true. They're not. And I know that that's not true, because I worked with kids for many, many years. So I just want to let you know that one of the tools that I use when I do any sessions is I use the Oracle Math box of facts. My slides actually come from Oracle Math. a lot of them where I'll show you how to teach the basic facts so that you can actually move it forward to the bigger numbers and the decimal numbers. Origo Math it comes from Australia, and it is a visual, because I'm a real believer in it's no use just teaching the rules and how to do things if they don't actually understand the quantity. And so this is one of the resources that I use. Another resource that you will see today, I might have time to show you a video or two from Origo 1 Minute Math videos. And I've given the link in the sheet, in the um, the sheet that I shared with you at the beginning. It's got a link to all of their playlists. I really like them because they're only a minute long, and it'll just refresh your memory. Like, oh yeah, what does she say about that strategy? Like I can't remember how to teach that, and it's really good because it wraps it up in 1 minute. The other thing is one of my favorite tools now, my favorite go-tos, is called the Figuring Out Fluency series in math. And it was produced by Corwin Publishers, and it's John San Giovanni is one of the authors of this book. So the very first book that I use it's just called Figuring Out Fluency in Mathematics. That book talks about all the strategies. Okay. And so it's really good. It's a really good teacher resource, just so that you understand the actual strategy. But then he put out two other books. One is Figuring Out Fluency, Addition and Subtraction with Whole Numbers. And what it's a companion book for teachers in it that it's got a bunch of lesson plans using the different strategies and helping you out with, just getting kids to think with numbers. It's like quick math talks. It's quick routines that you can use in class, but they're based on the strategies. And then another book he just came out with is Addition and Subtraction with Fraction and Decimals. And so for the one with decimals, he carries on with, in both of this yellow and this red book, he carries on with the strategies that he introduces to the teachers in the first book, but gives examples on how to use it in the yellow and red book. So those are a couple of my very favorite books. Now you need to know that this book here, the very first one, not only talks about addition and subtraction, it does talk about multiplication and division also. And of course, when he also has now books that are for multiplication and division with whole numbers, the companion, classroom companion, and multiplication with fractions and decimals, is a classroom companion. One of the things that he says in his book is fluency practice is not a worksheet. It's not a worksheet, and it's not about speed or recall. It is about learning some strategies and making kids think about them and think about the numbers that they're working with and make some sense out of it. And NCTM is the National Council of Teachers of Math and it's an international teacher group, just like your ATAs. This is an NCTM it's an international group, and they define procedural fluency as the ability to apply procedures efficiently, flexibly, and accurately, and to be able to transfer procedures to different problems and contexts, or to build or modify procedures from other procedures. Once you understand one, can you move it? Can you generalize it? Can you make it go to a different number? And recognize, the big thing is, can they recognize when one strategy or procedure is more appropriate to apply than another? And so I just want, before we start with anything, I just want to show you that there's three definitions I really want to go through. One of them is, what is efficiency? What does that mean? And out of John's book, and I keep forgetting about Jennifer Williams. She's the other author, but I know John, so this is why I always bring up John. But he says, they say efficiency is solving a procedure in a reasonable amount of time by selecting an appropriate strategy and readily implementing that strategy. Flexibility is knowing lots of different procedures and applying and adapting strategies to solve a procedural problem. They say that efficiency is solving it in a good amount of time, but flexibility is taking all those different procedures and saying, okay, I know how to use this. Now this is what I'm going to use, which problem I'm going to use it with. And then the last definition is accuracy. It is correctly solving the problem with accuracy. So in order to ensure that every student develops procedural fluency in our classrooms, a couple of the things that NCTM says is conceptual understanding must precede and coincide with instruction on procedures. Don't teach a procedure first and then explain why it works. First, go through the conceptual understanding so kids actually understand what is going on, and then they will tell you why it works. Procedural fluency requires having a repertoire of strategies. And they say basic facts should never be taught using using number relationships and reasoning strategies, not just memorization. Our memory fails us, especially when we get older. Hello. But if we have strategies and we know that it's not all about speed, then we can do a lot more with the numbers. And assessing must attend to the fluency components and the learner. Unfortunately, a lot of our assessments only assess accuracy, and therefore they neglect efficiency and flexibility. And so what they say is we should have tasks that show us whether or not kids can actually apply a strategies efficiently and flexibly. And so that's where they came out with those second and third books in the series for adding and subtracting, because those books will give you some strategies. But I'm going to go through some of those strategies today, and you'll see what I mean by some of them are just like phenomenal. So before I start, I love using this video when I am talking about kids, and when we often hear our kids don't know their basic facts, and then some of our kids think I will hear from teachers, yeah, my kids don't read, they can't read. Well, never mind, they can't read, they can't even understand what they're talking about. So this video, it is a grade 8 students. It is grade 8 students where Robert Kaplinski, he's another math teacher from the States. He goes out and he asks these grade 8 students this question. And I have to tell you, I did this question with a junior high school because I didn't believe that kids would do this. And you know what? I have to tell you, they did. They did. The question is, there's 125 sheep and 5 dogs in a flock. How old is the shepherd? Like what? And so I'm just going to show you the video that goes with these 25 kids in this class. Listen to what they do. Oh, before I go on though, I really want you to carefully listen to how the last student solved the problem. Okay? But watch there's 32 kids in the classroom. Can you hear this?
How old is the shepherd?
What? There are 125 sheep and 5 dogs in the flock. How old is the shepherd? I don't know how to solve this
Why is that?
because it doesn't talk about anything about the shepherd. Like, doesn't say how old, like how long he's had them or anything. So it doesn't give me any hints about anything. Yeah.
Okay, thank you very much. There are 125 sheep and 5 dogs in a flock. How old is the shepherd?
120 years old.
How do you know it's 120? Can you please write down here? Now, how do you know that the shepherd's 120 years old?
I was subtract 125 minus the 5 dogs in a flock.
Okay, thank you very much. Can you tell me, how did he know to divide?
Because it doesn't say the difference, or it doesn't say the sum, or the product. Or
I see. Okay, thank you very much.
Yeah.
That's whoop, just going to get rid of this. That when I saw that for the first time, I thought, unbelievable. I don't believe this. And I went to a school and I was working with a grade 8 class and we were working on math. And then I said, oh, by the way, I have a really good problem here. And I asked them this, and oh my goodness, I couldn't believe that kids automatically started writing numbers and doing some kind of math with it. And that's pretty accurate. And so one of the things I did was I went across the hall. I was in a school where the kids didn't know me, and I just knew the teacher, but she never told them that I was the math consultant. I told her not to tell them, and I went in, and it was the language arts or social studies class, and I asked them the same question. Do you want to take a guess how many of those kids got the right answer? It was also grade 8 kids. Anyone?
Did they all get it if it was English?
Yep. Take those kids out of a math class, and all of a sudden they start making sense of the math problem. Like they started looking around, and I said, don't talk, just put your answer on like a piece of paper on your desk. And so I'm walking around, and a lot of them are going, there's no answer to this. And I'm thinking, crazy. And so I really think it's time that we start helping kids understand and make sense of problems. And one of the things that, like I said, I taught for 37 years. 25 of those years I was in a classroom and I had posters on my wall that I used to define words like sum, product, difference. And I called it the keyword strategy and said, look for the keyword in that problem. Well, those of you who are in Division 2 or 3 will know that not all problems can be solved by looking at a keyword problem. I was in junior high and I was telling them, let's look at the sum, let's look at the product, and 99% of the time, it didn't have those words in the problem. And so this article, Avoiding the Ineffective Keyword Strategy, is a beautiful little article that I gave you a link to. And just take some time to read it, because do you remember what that girl said that was the 32nd student? She was looking for the key word. She was looking for the word sum, product, or difference. She knew those words, but she didn't know the word quotient, so it must be divide. And so she decided to divide based on not seeing the keywords that she knew, that she was aware of. And so if I was to do things over again today, I would take down that poster that I had on my wall. I would shred it up into pieces and not have it up there, because I wasn't doing my kids any favor by telling them that they had to look for keywords. Avoid teaching that phrases that say altogether, in all, or me, or more mean to add, or words that say left, remain, or fewer indicate that you have to subtract. Those don't always work. And so also what I want you to know is, as you know, as adults, there's some math that we don't want students to have to use paper and pencil for. There's some math and we're going to start today with addition and subtraction, that we just want our kids to think about the numbers that they're working with and do the math in their head. And always ask themselves, does my answer make sense? And so the key understanding for computation is that they, first of all, have to understand place value of numbers. And they also have to know their basic facts. Knowing that together will help them do any calculation with whole or decimal numbers majority of the time in their head, or being able to do an algorithm and say, yeah, my answer makes sense. So just a quick review of place value. I have these place value houses that I think are amazing. And Emily, if you're still there, I hope you agree with me now that I showed you this last time. But
yes, they're fantastic. I love them.
the place value houses, if you have a place value chart, I say get rid of it, because first of all, you know, in Canada, we do not use commas. And so a lot of place value charts that we buy are manufactured in the States, and so they will have a comma in them, or if they don't, they just are a run-on. Whereas these place value houses that come from, it's a New Zealand product, and I gave you the Black Line Master in my things, but the ones are the trendsetter house. So there's the ones, tens, and hundreds, and then we have the thousands. And the thousands have the ones, tens, and hundreds. And then there's the millions house that has the ones, tens, and thousands. And then there's the billions house that has the ones, tens, and hundreds. And so you'll notice, if you were to ask your students, what do you notice? They would notice that each house has a 1, a 10, and a 100. And then my question would be, what is the difference between the 100 in this house, or the 100 in this house, or the 100 in this house? And what we want kids to say is, these are 100 ones, these are 100 thousands, these are the 100 millions, these are the 100 billions. And there is a huge difference between those. But understanding place value also means that you have to understand that there is a decimal point. We, instead of saying decimal or point or dot, or we should be saying and the part of the whole. And the next house is the parts of the whole, because those ones are divided into, they're either tenths, hundredths, thousandths, 10,000s, 100,000s. And I know that we're only going to be working with tenths, hundreds, and thousands, but I want kids to see that those, you can keep splitting those pieces further and further by 10. And I want kids to know that every spot to the left is 10 times greater. And every time we go to the right, it is 10 times less than the one in between it. So that is really important for kids to know and understand, really understand how numbers are made. And then I want them to understand the word decimal fractions. Decimal fractions are fractions where the denominator is a power of 10. It's either a 10, 100, or 1,000. And those fractions or those decimals can be written as a decimal or as a fraction just by listening to the word. Like, for example, 1/10 can be written as a decimal, 0 and 1/10, or it can be written as 1/10 as a fraction. Please notice I didn't say 0.1, and I didn't say 1/10. The reason I didn't say that is a positional type of language that is, you're not doing your kids any favors if you're using that language, because we don't, when I say the number 524, I don't say 524. I don't say 5 before 2 before 4. I don't say 4 after 2 after 5. Like, there's a lot of thinking that has to happen when you're giving positional language. If we say those words, those numbers properly, we're actually giving them a value. So for example, 1/10 can be written as 0 and 1/10, or 1/10. 100 can be read as 0 and 100, or 100. 1,000 can be read as 0 and 1,000, or 1,000th as a fraction. So if I said the word, then kids should right away see I can write that as a fraction or as a decimal right away. So for example, if I said 1 and 281 thousandths, I should be able to write it as a decimal or as a mixed number right away. So we also, in kindergarten, we start partitioning whole numbers. We say, how many ways can you make 5? How many ways can you make 10? In grade 1, we go, how many ways can you make all the numbers to 100? And then in grade 2, we start to all the numbers to 1,000. And what I mean is 526. It could be, 526 could be 500 plus 20 plus 6, if we're doing it in expanded form, but it can also be 6 plus 20 plus 500, or it can be 400 plus 120 plus 6. And so if your kids know how to do that, then they should be able to do this. How many different ways can you partition 5 and 2600ths? So these are some really great 5-minute tasks that you can do in your classroom. Just put a number on the wall, on the board, and I would start with a whole number and then move it to a decimal number and say, how many ways can you make that? How many ways can you make 942, for example? Well, if you can make 942, how many different ways can you make 94 and 2/10? And what I want kids to see is I can partition decimal numbers the exact same way as I can whole numbers. That is really very, very key for them before you start trying to do mental math with them. Okay, so now let's get into addition and subtraction. And let's first of all understand what it is to add and subtract. This comes from the first steps in math. And I gave you a link in your handout that I'll give you again at the end of today's session. But this is the different situations, and kids need to know that addition and subtraction has different situations. So for example, you can join some books will call it the join situation, some will call it the combine situation, but that's when the story is about something being added to an original amount. And an example is Larissa has, so many cameras. She bought so many more new cameras. Now she has a total of so many cameras. Now I could write that as blank plus blank equals blank. Or Larissa had 52 cameras. She bought 2 new ones. Now she has 54 cameras. Or you can have a separator change situation, and that's where something's being removed from an original amount. Larissa had 54 cameras. She gave her aunt 1 camera. Now she has a total of 53 cameras. Or it could also be 53 plus blank gives me 54. Or compare equalize is where you're comparing 2 quantities. This one seems to get kids very, very confused. When Larissa has, let's say Larissa has 18 cameras, her aunt has 10 cameras. How many more cameras does Larissa have than her aunt? A lot of kids will add those questions because they don't understand. You're comparing like which one has more or which one has less. And then I totally love, and I would, if I had a class now, I would put up a part whole chart, because this really helps kids see, it's about combining different types, of objects, not FF objects, of objects. So for example, Larissa has 18 professional cameras and 2 iPhone cameras. So now how many cameras does she have? She has 20 total cameras. Or you can also use the part whole to help kids understand what are they looking for. It helps us relate addition and subtraction and to understand the properties. So for example, when you know both parts, like for example 9 and 2, you're looking for the result. So that's a result unknown type of question, 9 plus 2. But you can also have a change unknown question. And a change unknown is where you know an amount. You don't know how much you're either adding or taking away, but you do know the total amount. So this one is 8 plus blank gives me 10. And this is a start unknown. Kids really have a hard time with the start unknown questions, where start unknown is I had some apples. My mom gave me 8 more apples, and now I have 10 apples total. How many did I start with? So help kids understand this part whole. I would I would have just even this 2 parts and an unknown, and just when you're asking kids, say, do I know the start? Do I know both parts? First of all, if I know both parts, it's a strictly addition question. If it is a part that I know, but the other part I don't know, it can be solved by adding, or it can be solved by subtraction. 8 plus what gives me 10? So I know automatically that that's 2. Or I can go 10 minus 8 gives me the answer, or 10 minus blank gives me 8. And the same thing with this one. But if you're missing one of the parts, it can be solved either by adding or by subtraction. And we're going to start off right now with how to teach those basic facts so that they have strategies for the bigger numbers. Having instant recall of basic facts is really important. They're needed to develop that flexibility, but please, it doesn't mean that they have to memorize them, because if they know strategies, they don't have to memorize. Memorization actually becomes a result of the understanding. And they have found that students who learn through strategies outperform those who memorize their strategies. So again, kids who do not understand numbers or operations, they're really not even in a position to start developing this repertoire of strategies. And the teaching sequence, and please remember this, when we are teaching any strategies, the teaching is, first of all, introduce the strategy. Tell them what is the strategy. Reinforce the strategy by doing some kind of activities, maybe play some games with the kids that are based on those strategies, and then practice the basic fact. I know in grade 4, 5, and 6, we really do not have much time to practice basic fact, but my thing is, you don't have time not to teach the basic fact if they don't know it yet. Once they have got that, then you can extend that strategy to larger numbers and decimals. And so take 5 minutes at the beginning of a math class and do a strategy and help kids work with that strategy. Maybe for one whole week, do one strategy. This, the strategies that we're going to be going through, I have given you the strategy. I've given you a sheet with the description on what it is, and then examples of just that strategy, from going with the basic fact all the way up to larger numbers and decimals. And don't think there's that many. There's only 3 strategies. Okay? And it's also the same 3 strategies for subtraction. So we're not going to be here forever till 7:30 at night. We are going to talk about how can we take those 3 strategies and start combining them, and so that we can build some fluency in our classrooms. The first strategy is the count-on strategy. Okay. Second strategy is I need to know my doubles and my near doubles, but I need to know my count-on strategy before I start my doubles and near doubles. And the third strategy is the bridging to 10. That's it. 3 strategies. And if we know those 3 strategies, there's so much mental math we can do. So let's start off with the first strategy, counting on. I know that a lot of people say counting on. Okay, there's some numbers that you don't count on for. Like if you were just gonna use the count on strategy to solve this problem, 16 plus 27, I know I've heard teachers say, okay, we'll count on from the larger number. Well, you know, in this case, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44. Oh my gosh, I need to remember when to stop. How many numbers have I counted already? Counting on, like there's so much you have to do if you're counting on the big numbers are too big. Like if you're keeping track of 3 groups, you have to count the 2 parts being added and the whole. You have to say the numbers forwards and loud. You have to keep track of the numbers that have been said. You need to know the answers the last number said. If they're not familiar with counting backwards, some of them might not even be able to count backwards. That's really demanding. So let's bring it down and know that counting on by more than 3 is inefficient. It's an unreliable strategy, but it is a fantastic strategy if you're counting on or counting back by no more than 3. So what I mean is this: the count on strategy is simple. I'm counting on by 1. I'm counting on by 2. I also need to know that I can count on by 0. And for kids already in grade 4, 5, and 6, they should be able to count on by 3. And so, for example, what we do is we need to also include that commutative property. So when we do that, when we say 1 more than 6, 6 plus 1 is the same as 1 plus 6. If they can see that, then there's actually only 55 facts that have to be memorized. And what we want to get to is knowing that, for example, 1 more than 6 is 7. Knowing 2 more than 6 is 8. 3 more than 6 is 9. 2 more than 1, 2 more than 2 is 4. 3 more than 2 is 5. Okay, that's the strategy. So if you know that strategy, if you know that 2 more than 6 is 8, use that same strategy for 2 more than 36. Also use that same strategy for 20 more than 36. And so I have people say, well, how is this the same strategy? Because you're adding on 2 more 10s. And so when you're adding on 2 more 10s, all of a sudden you can do this. You don't need to line them up and do a algorithm. That's a pretty simple one to do, but kids need to know that 20 is 2 10s, and know that this is also 36 plus 23 is the count on strategy. I am adding on 2 more 10s and 3 more 1s. So this is actually 59. I could do it from left to right, right to left. It doesn't matter. And so once I know that strategy, you'll notice, I'm just going to go back here. You'll notice when I'm practicing it, one of the add-ins only has 0s, 1s, 2s, or 3s. Because I want to encourage kids I want to empower them so that they can do this. So this is what I mean by doing it all week, just doing the count on strategy. So do this same thing with decimal numbers. If you can do 36 plus 23, it's the same thing when you are doing 3 6/10 plus 2 10ths. So you're only adding 2 more 10ths. So this is now 8 10ths. Or 3 6/10 plus 2 1/10. Same thing. It's 2 more whole numbers and 1/10 more than 6/10. Same thing here now. It is 3 6/10 plus 23 hundredths. Well, I could say that 6/10 is the same as 60 hundredths, but I don't have to, because you know what? I can just sit and I should be able to say that this will give me 83 hundredths. Again, it is so important that they understand place value. So count on facts is the same thing when you're doing 40. Which add-ins do I stick to? One of the add-ins can only have the digits 0, 1, 2, 3. So when I go back, for example, here, when I'm practicing with the kids, I would own one of the add-ins, like this one has just a 2. This is a 2 and a 1. This is a 2 and a 3. But I would just want to make sure that when I'm practicing, like, for example, if I was just to ask you to use this strategy and I gave you the numbers 4 and 45 hundredths plus 3 and 2 hundredths, then I know that the 3 is, 3 more than 4 is 7. And then there's no tenths. So that's going to be 4 tenths, and 2 more hundredths than 5 hundredths is 4700. So I'm going to end up with 7 and 4700s. But did you notice that one of the add-ins only had I just used the combinations of the digit 0, 1, 2, 3. Okay. And so same thing here. 40 plus 35 is the same as 40 plus 10 plus 10 plus 10 plus 5. Okay, so it's 3 more 10s and 5. 167 plus 23, it's the same as 167 plus 2 more 10s plus 3 1s. Or 1 and 67 hundredths and plus 12 hundredths is the same as 1 and 67 hundredths plus 1/10 plus 2 hundredths. And I'll just move them through that and practice these, 5-10 minutes at the beginning of every math class, and one strategy at a time during the week. And then the next week we can get them on to another strategy. But take a look at this. If we did that, this is the 1 mores. This is the 2 mores. That's 0 more. And if you look, you'll notice that we actually have got almost half of the basic facts covered in 1 week. Okay. And then if you added the 3s, then we definitely are more than half of the table. So the second strategy is they have to know their doubles. This is huge. And I always tell my teachers, in grade 3, when you're teaching your basic facts, spend more time on the doubles than anything else, because if you know your doubles, then this will really help you with multiplication also. If you know your doubles, then you can do your 2 times table, your 4 times table, and your 8 times table just by doubling. But spend lots of time on doubling. And so in grade 4, 5, and 6, if I'm going to be using this strategy, I might at the same time teach my 2 times table, my 4 times table, and my 8 times table, because it's just the double, just doubling. So if I know double 6 is 12, then I know that 1 more than 6 is 7, then I should be able to do 6 plus 7, knowing it's double 6 plus 1 more. Or if I do that, if I knew that, then if I know that 2 more than 6 is 8, if I already know that, then I should be able to do 2 plus 8, knowing that that's double 6 plus 2 more. Now, if you just take a look at these cards that I'm using here, these are the actual cards that come from the kit. And so I just made slides out of them just because I love them, because they're very visual. So I know that someone here was, what's it called? I have to go back through my very beginning, but I noticed someone here was doing a strategies class or an instructional coach. There are some things, these are really great for kids that have a problem and they need things visual, and they may be visual learners. But anyway, the other thing is I like kids to see using bingo chips. What are 3 different doubles that we can use? 3 different doubles that we can use to solve 4 plus 6. Anyone? What's 1? You can put your mic on and just speak. What's 1 of the doubles?
4.
Yeah.
4.
Double 4 plus 2 more. It can also be double 6 minus 2. But what we really want our kids to see is that when one of them is 2 more, we can actually add the number that's in between. It's a double 5 also. Okay. So if we want to help our kids, if you have kids that don't know their doubles, you can always do pictures with them, like double 1 is 2. Double 2 is a dog that has 2 legs in front and 2 legs in the back, and they have 4 legs. But I learned something when I was doing this with a classroom. Never say always, because some dogs are missing a leg. And I learned that when I was doing my double 5s, but I'll show you in a second. 3s, you can talk about muffin tins. Kids also wanted to talk about the Tim Hortons box of muffins, but I use the double spider. I mean, for double 4s, I use spiders. We had a whole discussion. Do we want to use octopuses? But I said, oh, let's leave that for later. But we used hands for double 5. And this is where I found I made my big mistake. I said, come on, we all have 5 fingers on each hand. So how many fingers do we have? And they yell out 10. And then someone says to me, I'm missing a finger. And I went, oh, so you always know what 1 less than 10 is. Whoops. Okay. Double 6 is a 12. And this is also helps kids with understanding that 12 is a dozen. Weeks, there's 7 days in a week. And so 2 weeks has 14 days. That was a really hard one for us to find a visual for 7 plus 7. But 8, we used the octopus. And I liked it because it also got me into helping the kids understand the prefix oct. That oct represents 8. So it's 8 plus 8. And then 9 plus 9 is a semi is an 18-wheeler, which I was like, wow, like I was blown away by that, because as a city girl, never had any idea that that's what it was. So here are my count on strategies that we've already learned. Here's my doubles. And my doubles add 1 and my doubles add 2. Now, you can see I have learned almost my entire table. Now, when you know that strategy, that basic fact strategy, use it with greater numbers. If you know 5 plus 6 is the same as double 5 plus 1 more, or double 6 minus 1 more, use that same strategy for 25 plus 26. I'm not asking you to memorize 25 plus 25, but double 20 is 40. Double 5 is 10. So 40 plus 10 plus 1 more. 44 plus 46. I had kids that said right away will say, well, that's the same as double 45. Okay, so that's double 40 is 80 plus double 5, that's 10. Now, if you know that, go further. And now you will notice when I'm starting to practice these numbers, I am going to make sure I'm going to work really hard as for picking add-ins that are no more than, and if I'm working in the hundreds, no more than 100 more, 200 more, or tens, no more than 10 more, 20 more, 10 or 20 more, or no more than 1 or 2 more. I want kids to really use that doubling strategy. And so, for example, when I'm adding this one, I want kids to say, well, I know that 400 plus 400 is 800. 800 plus 1 more is, now I'm at 900. This is the same as 30 plus 30 plus 10 more. So that's, sorry, it's 30 plus 30 is 60 plus 10 more is 70. So now I have 970 plus double 4 is 8 plus 1 more. So I'm just putting them horizontally. I'm not lining them up, because when you line them up on the board or on your smart board, you're making them automatically think about doing an algorithm. Whereas this one, they can really see, can I just do that double strategy with these bigger numbers? And so the same thing goes. 125 plus 125 is the same thing as double 100 plus double 25. The older they get, the faster they can do this. They don't have to go double 20 and double 5. They can say, I know double 25 is 50. 235 plus 245 is the same as double 200 plus double 35 plus 10 more. Or 6 and 4/10 is the same as double 6 plus double 4/10. So, oh wow, 12 and 8/10. And if you're dealing with numbers in the hundreds, you could easily use dollars and cents and say $12.35 plus $12.35 is the same as double $12 plus double 35 cents. And the last strategy, super easy, is the number of facts in this cluster have to have an addend that is close to 10, 100, or 1,000. And so when we start off with the basic facts, we want them to think of being able to move quantities around and knowing that 9 plus 4 is the same as 10 plus 3. Can I do that in my head? Well, if I can add anything to an 8 or a 9, then I know that I can just move around those numbers and I can actually make it a number that I can work with easily. Use that strategy with greater numbers. So if you know 9 plus 5 is the same as 10 plus 4, then what I want to do then is say 29 plus 15 is the same as 30 plus 14. 398 plus 56 is the same as 400 plus 54. Use the same thinking for 1 and 98 hundredths plus 2 and 45 hundredths. Well, that becomes the same as 2 plus 2 and 43 hundredths. Do you see how we've taken up to 2 numbers from one of the addends and moved them over? And so this becomes a real blessing for kids to, when they see that they can actually do, especially adding decimals in their head. Are you kidding me? But yeah, you can do this. Let's empower those kids to do that. So use that same strategy with decimal numbers. So for example, 7 and 8/10 plus 3 and 6/10 is the same as 8 plus 3 and 4/10. Can you do this one in your head? What's 3 more than 8? 11 and 4/10. Okay, so the bridging to 10, here's plus 1, here's plus 2. There's the ones that I already knew from the last 2 strategies. Here's these 2, and guess what? It leaves us with 3 facts that we haven't covered. The plus 3, 6 plus 3, 7 plus 3, but by grade 4, they should know that 3 more than 6 is 9 and 3 more than 7 is 10. But 4 plus 7 is 11 because it's the same as 7 plus 4 is the same as 10 plus 1. And now they're combining some of their strategies. So I want you to know that the numbers that are under here that are also purple, they have 2 strategies that they could use. Here, these ones that should be, that can also be blue or green, so they can be close to 10. And these ones are not only close to 10, but they are also doubles. So there's so much now that they can practice, they practice. And now what we're going to do is we want to encourage our students to start putting things together and being flexible with their strategies. So for example, we want them to use place value when adding. So for example, 25 plus 33, they know that they're adding their place values. They're 20 plus 30, plus 5 plus 3. Okay, 37 plus 16 is the same as 30 plus 10 plus 7 plus 6. You don't have to have a paper and pencil handy. You do not have to line anything up. Use your knowledge of place value. So 23 and 60 hundredths and 4 and 35 hundredths is the same as 23 plus 4 plus 60 hundredths plus 35 hundredths. Or think dollars and cents. 1 and 4 tenths plus 4 and 3 tenths plus 3 and 1 tenth. Well, it's the same as 1 plus 4 plus 3 plus 4 tenths, 3 tenths, 1 tenth. Can I do that in my head or what? Of course I can. But kids aren't given enough time to build that fluency, build that efficiency by, just doing the easier ones. Now you'll notice here, when I'm going through these strategies, I am not making you add, for example, let me give you a question here. 4,821 and 14 hundredths plus 2,118 and 48 hundredths. I'm not doing that to you yet because I want you to build your confidence with these small numbers. And by me throwing in a decimal here or there and just showing you that, hey, I can do this. When we get to those numbers, trust me, it's going to be one of these. You're going to go, whoa, how come I didn't know this before? The associative property is also called using compatible pairs. So, for example, if you're adding more than one addend, you look at what you're adding, 3 plus 9 plus 7. Well, it's the same as 3 plus 7 plus 9, right? So I can do that and say 10 plus 9. But I mean, I start with little numbers and I keep getting harder. So 23 plus 9 plus 7, it's the same as 23 plus 7 plus 9. And I just did that in my head. I know some of you might be thinking, well, I can do 23 plus 9. I know that is 32. I know that plus 7. I did that, no problem. But when we're working with kids, they don't know that yet. And the same thing when I'm adding decimals. 1 and 9 tenths plus 2 and 7 tenths plus 3 and 3 tenths plus 4 and 1 tenth. Well, let's group them with compatible pairs. Is there a pair that I can group them with? Yeah, I can go 1 and 9 tenths plus 4 and 1 tenth. And I can group 2 and 7 tenths and 3 and 3 tenths together. And I can easily do this one and get that's 6 plus, 6. And that's 12. 150 plus 70, 175. When I'm working with kids, they might see it as 150 plus 150 plus 25. And not have to use paper and pencil to do that. The other strategy that we teach them is rounding it and adjusting it. So for example, 39 plus 28 is the same as 40 plus 30, take away 3. Right? So I've rounded the 39 to a 40 and the 28 to a 30. And so then I have to take away the numbers that I've added on to the beginning. 23 plus 19 is the same as 23 plus 20 minus 1. 49 plus 12, same as 50 plus 12 minus 1. 7 and 8 tenths plus 3 and 6 tenths is the same as, move it around, it's the same as 8 and plus 3 and 4 tenths. 11 and 95 hundredths plus 13 and 95 hundredths is the same as, move it around, take the 5 hundredths from 1, put it to, all of a sudden I got 12 plus 13 and 90 hundredths. Isn't that a lot easier than line up the decimal? Like, there's some things, why would I do that? Okay, another task that I really like is called as close as it gets. So what I do is I put up a question like 409 plus 1 and 19 hundredths. I'm not asking you for the answer. I'm asking you for which of those answers is the closest to the actual answer. I don't want kids to actually do the answer, but which one is it? The other one is 13 and 200ths. 13 and 2/10 plus 1,998. Which of those answers is the closest? And so you can also do it with the multiple choice, like which ones don't make sense, but which ones would be, which of these would it be? Well, I know it's not going to be 14. And I know it's not going to be 1,900, right? Do I know that? Okay, but which one of these, is this going to be closer, the answer going to be closer to 2,000 or 2,100? And ask, why do you think? Gets kids to do a lot of relational thinking. 36 plus 97 is the same as what plus 100? Anyone? Yeah. Oh. Okay, so Lexi, why would you say 39? That's okay. You know what? And I have to tell you, it's great when we make mistakes, because when kids make mistakes, we want them to see we've made the same mistake. So why would you think 39? Because are you thinking because you added 3 to one of the add-ins, you have to add 3 to the other add-in? Okay. You may have, because that is a common thing when we're doing addition, some kids will think that when we add 3 to one add-in, we have to add 3 to the other add-in, and that's not in the case with addition. It is the case when we're doing subtraction, because we want to keep the difference the same. So how about this one here? What did I do? This looks really hard. 3,554 plus 2,849 is the same as 3,403. Anyone?
Well, it's something with the 9 and the 4, but I don't know why. I'm still trying to figure out if you couldn't make it more simplistic by going to 10.
Of course I could. Of course
Okay.
I could. No, absolutely I could. But what I want kids to, what I want you to think about is, what do you think I did? This is a tough one.
You were rounding up your 2,849.
Ah, I made that 3,000. You're right. I rounded it off to the nearest 1,000. So I added 151. And so if I added 151, if I took off 151, I mean, if I added 151 to this one, I had to take it off of this one. Right? True or false?
False.
Why?
Because 19 plus 2 is going to be 21.
Perfect. That's all I wanted to hear my kids, my students say is because I already knew it was going to be more than 20. Okay. But you want to hear their thinking. Now, using manipulatives, using your base 10, 10 frames, you can help your kids understand also what is addition of decimals. So 3 and 2/10 is plus 2 and 3/10 would be 5 and 5/10, because I could take that and move it to my thing. Now, one of the things is kids have a hard time with manipulatives when we change the value. And when I say all of a sudden, well, I'm talking about my 10 frame being a whole. And so even though it's divided into tenths, now I know this is 1, 2, 3, and 2/10 plus 1, 2, and 3/10. And it really helps them see how this adds together. In grade 2, they use this as 32 plus 23. And now you're changing it up on them to them. But kids always say, but Mrs. S told us that this was 32. And yeah, you're telling us it's a decimal? Like, I don't get it. You want to make sure that you move those kids forward and say, I'm the human. I will give value to the manipulatives. The manipulatives don't always stay the same. The end. The other thing I really like is things like this. For example, showing kids that 6/10. If we have, if we take what's a hundredths chart, or if we take a grid paper, the 1 centimeter grid paper, it really helps us do this. So we could say that I could say 6/10 plus 25 hundredths. And they can see that, okay, 1/10, 2/10, 3/10, just like in here, this is 6/10, but 13 hundredths is 13 of these if they are, if that grid is divided into hundredths. And I can just show them, I could just add this on, but now I have 7/10 and 3 hundredths, which is 73 hundredths. And why is that? How does that work? And so these are really great models to show. So for example, 3/10 plus 3 hundredths is equal to 33 hundredths. But still, you know, if there was no lines there, that would be 3/10. And again, going to the very beginning of today's session, when I said what's really important is that kids understand all the different ways of partitioning, right? Now, I'm going to ask you to talk to me. What strategy would you use to add 257 plus 39?
Bridging.
Okay, how did you do that? Like, what kind of bridging? What did you bridge?
Well, I would take 3 from the 9 and make it 260 plus 30.
Perfect. Okay, someone else may, what's another way you could have done this?
I took 1 from 257 and made it 40 and 256.
Okay,
That's what I did as well.
okay. Now, how about just, if you did that, can you apply that same thinking to do 25 and 7/10 plus 3 and 9/10?
I would add 1/10 to 3 9/10 to make it 4.
And
Just
so
less decimals to deal with.
isn't that the truth? So yeah, whatever strategy you use with whole numbers, you can always use it with the decimals. Okay, how would you do 257 minus 39? Is there one of those numbers you would love to see it as an easier number?
260. I'd like 257 to be 260.
Okay, so you're adding 3 to that one.
Mm-hmm.
So then if you're adding 3 to that one, then you have to add 3 to the 39. So now you end up with 260 minus 42. Did that make it easier for you?
Yeah, because I'd like to subtract 2 from 10.
Okay, but can we do the other way? Can we try
Mhm.
saying, I want to make that 39 a 40?
It's 258 minus 40.
258 minus 40. Can you do that one easier in your head?
Oh, I'd really like that one.
Absolutely, you would. So if you did that and you made a 258 minus 40, then you can do that in your head. How about if it was 25 and 7/10 minus 3 and 9/10? Can you use that exact same strategy?
25 and 8/10 minus 4. So 21 and 8/10.
Beautiful. So what we want to do is we want to have more and more discussion on how did you do this and did it work? Will it always work? Adding on, now this you'll notice now I am talking more about adding on a number line, but I can say I start off with 136. I'm going to add on 100 on the number line. I get to 236. I add on 40 more, I get to 276. And I add on 3 more and I get to 279. It's not the exact same adding on as adding on by 1, 2, or 3, but it's adding on the place values. Adding on the 100. So you'll notice this is 100 plus 40 plus 3. And what I've done is I've just broken that down. Compensation, when adding, when I am taking from one to give to the other. So for example, 236 plus 297, I could say this is 300 and I get 536, but I've compensated by taking 3 from the other one. So now I have to take it away and I get 533. So, or I can just say, well, compensation can also be 200. I'm going to take away 233 plus 300. Okay. And then the constant sum is take 2 from 153, add 2 to the 598. So then what you get is 151 plus 600. And you can do that one easily in your head. Right? Oh my goodness. Who's that? Is that your son, William? Willem?
Yeah, this is my son, Michael.
Well, hello there. He's like, who is that woman? Okay. The number one strategy for subtraction is to always think addition. Think addition when you're teaching this, when you're helping them, and help kids know if you know 12 minus 7, think about what you would add to the 7 to get 5. I'm just going to show you this 1-minute video.
What thinking strategy should my students use to learn their subtraction patterns? The number one strategy for subtraction is to think addition. If they know the addition facts, they learn their subtraction facts much easier. Let's see the strategy with a picture card. Here, 12 is the total and 8 is the known part. What is the missing part?
If I use my knowledge of addition, I know 8 plus 4 is 12, so 4 is the missing part.
Correct. In this way, we just use the unknown add-in model of subtraction, which is very useful for connecting addition and subtraction, and we can also use it with greater numbers. Suppose you have $106 in your wallet and you want to buy a ticket for $89. How much will you have left?
Well, $106 is the total and $89 is the known part. I need $11 to reach 100 and another $6 to reach 106. So I should have $17 left.
That's right. Subtraction problems can be easier when we use addition to figure out the unknown part.
Okay, so think addition versus subtraction. The difference is what's the distance while you're adding up, and the removal is when you're subtracting, taking away, minusing. Now I'm just going to we're out of time, so I just want to go to defining an algorithm. What is an algorithm? Because this is now in our curriculum. What is an algorithm? Algorithms, they are structured series of procedures that can be used across problems regardless of the numbers. They promote accuracy and they are efficient. Now, this is one algorithm that we could always use, is just saying, okay, 200 plus 400 is 600. 60 plus 80 is 140 or 14. 8 plus 3 is 11. I don't like this myself. Because you'll notice that I said 600 plus 140 plus 11. And when I was reading this out thing, I was seeing that it's just giving you as a 14, but we're not adding 6 and 8. We're really adding 60 plus 80. But this is easy. I can now say, okay, well, if I have 14, or I can say 6, or I could say 6 tens plus 8 tens gives me 14 tens. 14 tens is the same as another 100. So now I have 7 hundreds plus 4 tens. And then I have 11 ones. And so when I have 11 ones, I have to bump it up and I have to regroup. I have 751. Now, I know it says standard algorithms in our curriculum. Who defines standard algorithms? I don't know, and neither does Alberta Education. It all depends on where you come from and where you've learned. And so also when you know this, you can use these algorithms also for decimal numbers. And so the traditional addition is, I can go 8 plus 3 is 11. I carry the 1. I don't carry anything, everybody. Please do not say anything. You carry, because what we're doing is we are regrouping another 10. I have 1 10, 4 tens, and 8 tens. That means I have 13 tens, which is I am going to regroup. I have now added another 100. I have 100, 300, 500, 931. And the same thing is happening when we do decimals. I love the partial sums that you could use. This is another algorithm that you can use. And it is basically, you can go left to right and go 300 plus 500 is 800. 40 plus 80 is 120. 8 plus 3 is 11. And then you just add those up. And the same thing with decimals. I'm just going to, sorry, it's just, I knew this was going to happen. Anyway, I gave you a beautiful little handout that I have that is the 6 methods of subtraction. Again, please be very aware if you have students in your classroom that are from different countries, because their so-called standard algorithm is different than our standard algorithm, or could be. And so we want to honor those kids. And this is an example of how these algorithms are different. It's called 6 methods of subtraction, and they're all different depending on what country you come from. And so for some students, the way that we teach them doesn't make any sense. And so we want to encourage kids that you can use your algorithm that works. Absolutely, you couldn't. But first of all, if I don't understand it, can you please teach it to me? And the second question I want to ask is this. Will it work every time? So check for reasonableness. I love this. It's choose, change, check. Choose, is this something I can do in my head? And what strategy makes sense for these numbers? I always ask myself if I'm doing something in my head, I always ask, is this a 1 more, 2 more? Like, is this a count on? No. Can I do it with my doubles? No. Can I do it with my, bridging to my nearest 10, nearest 100, nearest 1,000? If I can't, maybe then I'm going to have to use some regrouping of numbers. Can I do that? Find some. If there's not, maybe I have to resort to an algorithm. And is my strategy going well, or should I try something else? The thing always is, always have your kids at the very beginning do an estimation. And then, is my answer close to what I anticipated it should be? And how can you check your answer? Always ask yourself these questions. So I have 2 more upcoming sessions that I'm going to welcome you to. My first one is next Monday. I'm doing strategies for multiplication and division, basically the same kind of a session again, but it's now with multiplication. And there's only 4 strategies for multiplication. And you've already learned one of them. It's called doubling. And on Wednesday next week, I'm going to talk about strategies for teaching prime, composite, divisibility, square numbers, factorizations, and strategies for teaching those for understanding things that you may have not seen before. And that will be next week. And then I do have one the following week on area. If any of you teach grade 4, I'm doing one on area. But thank you very much, and thanks for staying late. And I'm just going to put this this here into the chat. This is my document that has links to everything that I talked about today. It even has my slides on there, and it's the last slide. And at the very end, it's got my email address if you need to contact me for anything. But on that note, thank you so very, very, very much for spending your Monday afternoon with me. I know some of you have today off, and so you're even here on your day off. So I really appreciate it. And then some of you, I notice you're in your classroom. I can see you're in your classroom, so I know you didn't have the day off and you're tired. You just want to go home. So thank you very much. Have yourself a great week, and hopefully I'll see some of you next week.